Welcome everyone to this session, one of the last sessions of the day. And we're going to be talking about how to build secure mobile apps. And we want to say thank you for two reasons. First of all, you guys are here even though there is a lot of free drinks out there, so thank you very much. And the second reason, which is even more important, is you guys are here because you actually care about security. And that makes us very happy because at Salesforce, we also care about security very, very much. So first things first, safe harbor. You guys probably heard about this over the entire day, so we won't spend too much time on that. And let me start by introducing myself. My name is Martin Vigo. I'm a product security engineer at Salesforce. And today here with me is Sergey Gorbati. He's a senior product security engineer. And we both work together with teams across Salesforce. And basically our goal is to help them during the development lifecycle to actually follow best practices in security. And we do so by starting from the design phase. We support them there. During the development phase, making sure that they are doing things considering security. During QA, and we actually do security reviews once we ship our products, new updates. So we constantly work with them. And today our talk, as you can see in our agenda, part of it is talking to you guys about the things we have learned through our work. So we want to cover three main points today. First of all, we're going to start looking at the ecosystem that we actually are talking about the mobile ecosystem. And we want to see what kind of threats we are exposed to. Next, we want to see how actually, from everything we're going to tell you, how we can do actually to develop secure mobile apps taking that into account. And last but not least, we want to talk about the frameworks. So we are going to talk the different platforms and then the frameworks that actually can run on those platforms and about actually their characteristics and especially focusing on security. We also have some very cool demos that we are sure you guys are going to like because we're going to have some life hacking here, and there is nothing better than having a talk on security and prove to you that what we said is actually true. So let's start. Let's look at how many platforms we have actually available. We have the two major ones, iOS and Android, and then we actually have BlackBerry and Windows. So all these platforms work differently. They have different documentation. They have different ways to look at security. They have different programming languages, but they all share one thing in common, and it is they support HTML app development. So you can write your apps actually using HTML and JavaScript, and that's through one of those frameworks that we actually mentioned before. So once we got the big picture of all the mobile ecosystem and all the different platforms we can develop on, let's look actually at what type of threats we're actually exposed. And we decided to divide that in two different ones, and considering that you actually can develop in frameworks too. We have the native mobile app threats, which those are explicitly the ones affecting the different platform, iOS, Android, and that what we mentioned. And then we also need to consider the web app threats when we talk the different frameworks. And we go into detail after. So when we look at the native mobile app threats, we have things like the file system. So file system means here the app sandbox. So what kind of information goes there? Is it secure? Is there a way an attacker can actually gain access to that? Does it need to be a rooted or a jailbroken device for that? And then we have things like DB storage. There is a lot of information that we want to store in, for example, SQL databases. But there is maybe a lot of information that gets stored there without actually us explicitly writing business logic for that. And many developers we have found over the time that are not aware of that. So what kind of information gets there stored automatically? Logs is actually a big thing too, because we as developers, while we are developing, we use the logs to debug for debugging information, right? We want to look at crash reports, we want to look at analytics, we need some information while we are debugging, so we use all those logging for that. But what should we do before we ship or to production? How can we avoid that information gets actually leaked? If we move on to network communications, what we are talking about here is the protocols. Are we using secure protocols to communicate with our different endpoints? Do we use encryption layers? And if we do so, do we do that in a secure way? That's another point we need to consider. The clipboard is just another way, actually, to store information temporarily. So we need to take that into account when we are considering security. So we will be talking about that too. Backups is very specific to mobile devices, right? And backups is just a place where we actually move our data that we may contain securely in our device, but suddenly we're backing it up to another machine, and we don't actually have control over that anymore, and we have to rely the security on the user's machine. So we need to control what kind of information goes into the backup. That's part of the security model. Then we have things like RPC and how applications actually communicate among each other. Can some like malicious app that is installed in the user's mobile device steal information from our app? How can we really use that sandbox to avoid that kind of things? So this is just a number of threats we're exposed when we are talking the native side of mobile development. But when we use frameworks, suddenly we have support for JavaScript and HTML5. So we need to consider things that affect actually the web, and that will be things like input validation. It is very important to keep in mind that the user input is malicious. It's a very good mindset to have while we are developing apps, because that will force us to actually always double check on the user input, sanitize it, encode it properly, and those things that we will later talk about. Another thing is, do we have a proper session management? And we put it there because through malicious input, we can actually maybe break that session management. So we need to have a very robust session management because we don't want to have an attacker impersonating our users. Then we have things like web app logic flaws. There is a recent bug on Cordova. I don't know if anyone heard about it, but from the internet, you can actually launch malicious intents. That's very, very bad. So, and that affects the app logic. Or imagine that you have, for example, you secure your phone with a ping, and suddenly with tools like Browser for Android, you can actually bypass that logic. And suddenly, you bypass the only secure layer that you have for your mobile device, for your app, sorry. And then, of course, like more specific to web, like cross-site scripting, like CSRF, or like all types of injection, not only SQL injection, but actually manipulating and tampering headers. So this is just a brief overview over some of the threats that we are exposed to. But now that we have that high-level overview, we want to go specific on each of them, and we want to talk to you the things that we have found and what you actually should be doing to prevent it. And we can start, as we said, on the file system. One of the things is the excessive logging. As I mentioned before, it is okay to put a lot of logging while we are developing, but it's not okay to ship the app like that. Reason being is passwords can be leaked, because usually when we are developing, we just print out, for example, entire objects. So maybe we just need to know that the user is actually an ID, but we print the entire object and it goes all the personal information with it, maybe even including passwords. It can also happen that we log URLs just to check the endpoints that are hidden. So if we have secrets on the URL, which we shouldn't, such as auth tokens or session IDs maybe, that's going to get leaked in the logs too. So it is very important that before we ship, we disable NSLog, for example, in iOS, and we just really go through and pen test ourselves to see what actually our app is really putting in the logs. And that is very easy. In Xcode, you can do that, and you can just see that real time. So how about storing secrets? So there is things that we need to store in order to have a certain usability in our apps, right? We don't want our users to having to enter their credentials all the time, so we need to have some kind of cache there. And so how should we store credentials? And especially, how do we store any sensitive data? Because we are not talking only credentials, but we can talk session IDs, personal information, emails, and things that are really sensitive and shouldn't be leaked. So you should never hard code the secrets. And I'm not talking only credentials, but for example, when we want to do a secure storage, we may decide, okay, let's just encrypt it. Reason being is, the secure storage, which is the keychain, is actually not very good at storing large files, but it's more like a database where you store data. So one of the things you can do is actually encrypt your data and store the encryption key in the keychain. Never hard-code it, never hard-code anything, and the reason is any reverse engineer, you don't need a lot of knowledge because there is a lot of tools that are free, open source out there that will do the job for you. For example, for Android, it is pretty trivial to actually reverse engineer the app and actually decompile it, not even reverse engineer it. In iOS, it may be a little bit more difficult because basically what happens is that Apple encrypts the app and signs it, and that's actually the reason why we can't run third-party apps in the phone that are not on the App Store. But still for that, there is tools out there that you can actually brute force the encryption and still get that decrypted. So things you need to keep in mind, don't hard-code your secrets. Use the keychain for the important piece, credentials or encryption key, and then just encrypt your data in the app sandbox. We need also to consider cache data. Once again, as developers, we want usability. Usability comes with caching, especially on mobile devices, because we want to have a nice user flow. So what kind of caching happens there? There is explicit caching that we as developers actually code some business logic to have it, but there is actually some caching that happens behind the scenes. And that happens in iOS and that happens in Android. So we need to check on that because there is things like URLs even over HTTPS that gets cached. Or there is, for example, screenshots in iOS that gets cached. And that happens when you click the home button and it goes back to the home menu. What it basically does, it takes a screenshot. So when you open it again, it makes that nice animation of kind of making it bigger. So if you actually press the home button while you are entering your password or while you have some personal information, that data gets leaked, and then Sergey will do a really cool demo where you guys can see how easy it is to extract that. Let's look at network communication now. So network communication, we got to make sure we use encrypted protocols. We need an encryption layer because we will be handling with sensitive data. So, and with that, it comes certificates. So another common thing to do on the development phase is that we use self-signed certificates, right? So we found that a lot of developers actually forget to remove that business logic or to remove that restriction, not to add that restriction. So when they ship it, you actually can use self-signed certificates, so allowing like man-in-the-middle attacks, for example. You also don't want to bypass the root certification. There is some developers that add that logic there just during the development phase and forget to remove that before shipping to production. So again, before you ship, make sure that you are double-checking that you don't allow self-signed certificates and that you actually validate the certificates. Session management again. So, for example, how do we expire the session, right? When a user logs off, what happens? Are we destroying the data? I guess we should, right? Because what's the point if a user logged out of not actually destroying all the cache data? How about the session itself? What are we doing? Are we just really canceling or doing the logout just on the client side, or are we doing it on the server side? It is very important to do it on the server side, at least there, because anyone can steal the cookies and then just impersonate that person. So ideally, we do it on both sides. Also, now we have the use of IP range restrictions. Salesforce allows that, so we should take advantage of that as an extra layer of security. As I mentioned before, the clipboard, yet another place to store information. And with that information, it could be sensitive information. Tools like LastPass, it's actually the only point of the clipboard is to save the password and use it in another app. So many developers don't know that actually, for example, in iOS, what happens when you copy something to the clipboard, a message gets broadcasted. And other apps, including one that could be malicious, can be listening to that and actually get that data. So we need to make sure that no sensitive information makes it to the clipboard. And if we really have to do so, we need to control that doesn't get broadcasted or no malicious apps can actually steal that. And last but not least, the backups. As I mentioned before, there is ways to control what information can be backed up. We actually can explicitly, but we need to code that business logic to have certain information that does not get backed up. One simple way to do that is in iOS, for example, adding it to the cache folder. And this is very important because there is information that is sensitive that there is no reason to actually have it in the backups. Because even if the backups can be encrypted on the user machine, that's ultimately their choice. So we don't want to have another point of failure for our app. So that's very important to control what information makes it to the backups. So
let's change of pace. Let's do a small demo. So Martin talked about native app threads and essentially why is it a bad idea to store stuff in the, just in clear text in the app sandbox. So I'm going to do a demo of the iPhone app. So I'm using third-party software just to mirror the screen. Here you go. So I have an app.
Wait, it's not on the screen though. There you go.
Here you go. Essentially, the app that I have written, it's a really dummy app. It doesn't do a whole lot. It shows you like hello world and some text and very simple navigation. This is all good, but essentially, how can I, as a developer, go inside and look what this app is storing in Sandbox? Is it even possible? And it turns out it is actually trivial. There are tools out there like iExplore. The tools actually allow you to go and look at everything that is stored inside your Sandbox. All right. So here I have my phone connected, and I'll go and look at the. Wow, that's a small font.
Which one is the name? I can help.
Here you go. And essentially, I can look at what's inside the app. So what is the mechanism that this app uses underneath? Same thing that it uses to back up your phone. So if you can back up your phone, you essentially can look at what's inside your app. So you can look at the content of documents folder, library folder. The caches folder is where Martin was telling you that if you put data in the caches folder and you connect your phone to the iTunes for backup, that data will not get backed up. Or you can do the same thing with an API, setting the flag to do not backup. So the screenshots that Martin was telling you about, so when you hit the home button, if you hit this home button, and then I'll go restart. Okay, and I'll go back to the app, and the location where I was at the time will basically snapshot it. So it's right there. You can see that the iOS does this cool zoom in effect when you start the app, and that's exactly what it takes this screenshot from. But let's say if you were browsing your $1 million business and you had your financial report there, that screenshot is there. Of course, you have to have physical access to get to the device to see it, but it is not encrypted. Another cool thing is that the encryption on iOS is out of the box, but only if you have a PIN code set. But if you unlock your phone, there's no encryption anymore. So if you can get to trust iPhone to a certain device, then you can basically read all the data out. And what else do I have there? What if I'm a developer, I decide to put something else in here? You can see the cookies that come with Safari. It's all available. You can look at the preferences file and the developer decide to write stuff to. And if I'm a developer and I use, let's say, plist to write data to the file system, so here, and I will restart the app again, and I have written some data on a disk using a property list. Looking at the iExplore again, I'll basically go into the app. And here I can look at what is stored, and there's some secret, dummy secret that I put in there. But the reason is that NS URL dictionary or NS user preferences are just a file on the file system. So what are recommendations to address this problem? You can use projects like SQL Cipher. They're a transparent layer of encryption that basically you're talking like to SQLite database. But underneath the hood is actually properly encrypted on the file system. Okay? So that was a short demo of how to access the App Sandbox. And we'll continue back with our slides.
Okay, I just want to point out that that was not a jailbroken device. He just plugged it in and got access to the App Sandbox. So that's very important. It just takes to steal a phone, and you can do that. So we talked about the native app threads, and we did this slide already.
All right.
So once we talk about the native one, let's actually focus on the web app threads, which happens when we use one of those frameworks. So as we mentioned before, now we need to consider all the native threads plus the ones that apply to web. And those include things like I mentioned before, application logic flaws, that you can maybe bypass a ping screen, or you could actually get, as happened in Cordova recently, a malicious intent launched from the internet. So that is pretty bad. We need to consider that. And then, of course, as I said before, input validation. Always keep in mind, malicious data always comes from the user, so sanitize it, encode it, treat it properly. It's very important to escape that and consider that it's not benign. Output encoding is important too, because we want to avoid things like cross-site scripting, so this is very important. Then it goes hand by hand with the input validation. Header injections can happen too. And then we need to consider that we need to protect our sensitive actions, things like changing passwords or changing an email where your reset password goes. And we need to do that with CSRF tokens. That still applies when we use those frameworks. So we have in one hand the native threads that we talked about, and now we consider the web app threads. And when we looked at what we can do with the frameworks, we actually have that in-between hybrid apps that are actually very cool. And the reason being is that it gives you the capability to access some of the sensors, so actually native functionalities from actually JavaScript and HTML through a JavaScript bridge. So this is actually very cool. You can access things like the camera, the photos, accelerometer, and all those nice gadgets that come included in our devices. So I think we have another demo now.
So I'll put my developer hat away and put the attacker hat on. And so what does this slide told me? It told me that I can actually, from JavaScript, access all of the internals of the phone that are running on the native. So okay, I'm going to try to access it. Okay, so same app. Then what we're talking about. Essentially, this app is a hybrid app. It's built using a framework like PhoneGap, or known as Cordova. And essentially, this is HTML5. This app, let's say for a second, let's pretend that it's vulnerable to an attack called XSS. XSS is basically running third-party JavaScript inside your mobile app. Now, if I can control JavaScript here, then I can do some bad stuff. And how bad can it really be? That's a good question. So if I'm going to switch to the screen, so I'll show you a Beef project. Beef project essentially is a broad, wow, do we have an earthquake? So we have a browser exploitation framework. And this framework allows you to basically, if you inject JavaScript into some third-party app, this will allow you to actually control that particular browser instance. So I have this framework actually installed on my local machine. And what I'm going to do is I'm going to demo to you the vulnerable app and what I can do with it. So first of all, the phone, this phone is a mirror basically of my phone right here. So if I scroll up and down, this is a real device. And what I'll do is I'll go to the Beef framework and I'll show you what I can do. I can do some sensitive actions. I mean, to start with, let's have fun with the user. How about we just tell the user that they have been, like the screen, what they're seeing, let's just say suddenly will change.
Nice.
So the user is thinking, well, I'm browsing this app, but now they have a transparent iframe that is laid on top of the whole screen, and it shows the user a completely different context. So the user may have looked away from the app and then come back, oh, okay, I'm here in this app, so I'm going to keep using it, thinking that I'm using some other place. But meanwhile this happens, the attacker is not sleeping, so he's thinking, well, I'm going to go and actually, using the phone gap, I'm going to extract all of the contacts that are on the device. Okay? It takes a second. Come on. Nothing like live demos. All right, I think I know why. And the reason why is because I disabled in the privacy contacts. So contacts for this app on, and we go back.
You don't trust the wrong app?
Well,
that's good.
Okay, let's do it again. List contacts. Execute. This should basically ask my app, are you okay with this app reading all of your contacts? Anytime. All right, I'll just kill the demo and restart again. Here you go, and okay, oh, come on. All right, and you can see that all of the contacts, they have been extracted pretty much from my phone. And these are my contacts, so I'm not going to stay here for much longer. Now, what about other things? Can essentially an attacker ask the user nicely for some information? It turns out that it's actually really, really plausible. So here I would ask for some, let's say, Salesforce ID. Please enter your Salesforce password and execute. And now it's going to prompt with a model that looks exactly like iPhone pretty much native UI. And how many of us are trained to just enter this information because it just looks like it's coming from the iOS? So essentially, this demo is a quick way for you to see that it is totally possible to extract any data from a PhoneGap app that is vulnerable to an XSS just because it uses the bridge and connects JavaScript to the native side.
So with that, we have seen to everything we are exposed. We explain a little bit how we can avoid that, and we actually got some demos that prove that we actually tell you all this for a reason. So let's look at actually those different platforms like iOS, Android actually help us with what tools they provide us to avoid all this. And we actually looked at that. We looked at iOS and Android because they are the two major ones. And we found out that in iOS, there is actually overwhelming information. We have a huge document that is 120 pages long, and that it covers from very low-level things like buffer overflows to more high-level like web vulnerabilities. And we found that it was actually very difficult to skim through that document when you want to find something specific. Say, how do I do so certain information doesn't make it to the backup? Something very specific, which is very difficult to find. Now, on the other side, we have Android. In Android, we found a lack of information. We found about 6 articles on different topics, but that definitely doesn't cover anything. In these 40 minutes, we actually cover more than all these articles. So we have two worlds where we have too much information just in one place and where we just have a little bit of information in a number of articles. So once we know what the platforms actually, how they help us to make mobile apps secure, which is not very, very good, let's look how the frameworks actually will help us to achieve that. And we checked the frameworks out. And we saw that all of them obviously focus on rapid development, right? Because if not, what would be the reason to use one of those? So now most of them actually provide easy ways to have TLS connections. We want to have secure protocols. So most of them, they provide easy ways to do so. Now just a fair amount of them provide authentication support. And authentication support is key. We don't want to develop our own business logic for that because that's probably never a good idea. There is high chances we will miss something, and we don't want to reinvent the wheel. Just a fair amount of them actually provide that. Only a few of them provide actually secure credential storage, which pretty much all the apps have, right? Only a few of them. And very few of them provide secure data storage because we don't only store credentials. We want to store all other types of information. So that said, Sergey is going to actually explain how the Salesforce SDK helps us with that.
So if you ever decide to build a Salesforce mobile app, then you can use our force.com GitHub project that provides with the mobile SDK that is for Windows, for iOS, and for Android. This SDK is actually designed to address the problems that we just talked about. It is designed to use proper session management. If the data that needs to be stored safely on device, it encrypts it properly and stores the secret in the right place, like keychain. If your organization requires the user to type in a PIN code to protect the mobile app, like after a certain timeout from being wide open, those frameworks already support this. Of course, they use TLS and they provide REST kits that wrap around the REST APIs and allow you to just query like with an API instead of writing the actual like select name from account using REST. That is very convenient. The Cordova plugins, so there are native and there are hybrid mobile SDKs. You can pick the one that suits you better. The hybrid ones come with some plugins, and you can actually scope down the plugins. The way Salesforce designs the mobile plugins is actually like you saw, you can't really dump a whole lot of context from a Salesforce One app in the same fashion, because the way we design plugins is that we allow you to query the plugin and to search for specific data, but not to give you a whole list of everything. It's very context aware. And also the login is scrubbed to the minimum, so if any login was added to your mobile app, What else do we have? What should we do to actually take in all this information and move forward? If you leave now, what should you do to get your app to be secure when you try to go to the Apex security review or you publish it to the Apple Store? First of all, brush up on OWASP Top 10. It's an open web initiative. They provide you with all the modern threats, and they publish every year what are the most important threats to worry about. And also they provide mitigations and some tools to help you with that. We can certainly advise you to do, to brush up on the vendor recommendations and look at what Apple, Android, and Windows recommend you, how you should store data, how you should store secrets, how you should do authentication. You should exercise minimal logging and store secrets in the right place or use a right framework that does it for you. If your app creates any requests on the network, then it should use proper encryption. For your apps, you can be your own, attacker and pen tester. You don't really have to, go out and employ somebody. There are so many tools available out there that just let you, look at the app and see what's wrong with it. Very, very quick look. You can either start by looking at the source code with tools like Sandbox for Java or Brakeman for Ruby. ScanJS will scan your JavaScript files and give you some hints where the security problems might be. But you can also do more. You can download tools like Burp Suite Pro, which is Java tool, Fiddler for Windows, Charles Proxy for Mac. All they allow you to do is basically sit in front of your internet connection. So your phone tries to talk to internet and sits right in front of your internet connection. So you can basically see all the requests that your mobile app makes on the wire, how they appear, what cookies are sent with it, and what response comes back. In addition to all of those, you can also look up the tools like iExplorer is the one that I demoed today. It's a free tool. You can download the 30-day demo and just to see what's inside the Sandbox on iOS. Drowser is the analog of iExplorer, but for Android. You can also use ADB on Android with the emulator because it provides you full access. And essentially, you can start picking up knowledge of how to pen test your own app on your own. And most of this information, including sample vulnerable apps, are all also posted on the OWASP website. With that, we'd like to do a little bit of advertising. So today we're the last security talk for the day. And we also have a few talks tomorrow and Wednesday and Thursday on security topics. So if you're interested, please go check out how to protect your data against malicious scripts, how to protect your app with external integrations, or REST and SOAP and SSL. We also have some scanners online that will allow you to scan your code. You can scan your Apex and Visualforce and JavaScript using the force.com scanner. And our own take on how the web app scanner should look like is called Chimera, and we provide it to partners as well. Check out that link. With that, we would like to open the audience to any questions you may have.
And thank you very much for attending the session. If not, they don't clap.